Hi, welcome to Chapter 6, Section 6, Inverse Functions. So, whenever you're talking about finding the vertex, right, we say you do the inverse inside. So, this is the same idea. You have to do the opposite function, or the inverse function, to get rid of something. So if you were to start out with the parent function of a quadratic, right, y equals x squared, you swap x and y, so you get x equal to y squared. Then if you tried to solve for y, you would have to take the square root of both sides. Then you'd have to remember that whenever you take the square root, you get two answers, the positive and the negative. So y is the square root, is plus or minus the square root of x. And that's where the square root function comes from. It comes from taking the inverse of a quadratic. So they are inverses, which is why whenever you get rid of a square, you take a square root. To get rid of a square root, you square it. They're inverses. They undo each other. So the quadratic function and the square root function are inverse functions. Functions that undo each other are called inverse functions. So you can find the inverse function of any function, and it's not always a function, right? The inverse function is not always a function, but you can still find it. So let's deal with a linear function first. Okay, just a plain linear function. The first thing you do is set y equal to f of x. Okay, so we have f of x right here in our problem. So instead of putting f of x, you want to put y. Right? They mean the same thing. Equals 2x plus 8. That's step 1. Step 2. Switch the roles of x and y and solve for y. So, instead of a y, you should have an x here. And instead of an x, you put a y. Now we need to solve for y. So you would solve for y the same way you always do. You subtract 8. So x minus 8 equals 2y. You divide by 2. And y equals x minus 8 over 2. Now here's how you write the inverse function. You use f to the negative first power x of x equals x minus 8 over 2, instead of just leaving it as y. Okay, that's how you write it. Now this problem also tells us to graph the function and its inverse. So we're going to graph the function first. Okay, and I'm going to graph the function in blue. Alright, so I'm going to circle that. So remember, you can either use desmos.com to graph, or you could just plug in numbers, because if you were to plug in numbers like -2, -1, 0, 1, 2, you'd get some good points. So we have the points, and you can get this from Desmos, -2, 4. So we're right here. 1, 2, 3, 4. We have the points -1, 6. And that's actually wrong. -2 is right here. We have -1, 6. We have 0, 8. We have 1, 10. And there's your line. So whenever we draw this line, right, let's go ahead and draw it. It's blue. So we go all the way down. And we have our arrows because it is a line. Then we need to draw the inverse function. So again, you can put x minus 8 all divided by 2 into a calculator. You can just plug in x's, but when you do, you get these points. So I'm going to use black for this function because that's what I solved it in. And you have a point for -2. Six, -1, 8, 0, and 10, 1. So this is that line. And it has arrows. So this is a common theme amongst inverse functions. Okay, you will always see this. They reflect over the line y equals x. Okay, The line y equals x means that all of your y's equal your x's. So you get the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. That looks like this one. And if you draw that line, you can see pretty clearly that they are exactly the same on both sides. Okay, that's a reflection. So let's use this information that we've just found out to fill in the blanks below. So the inverse function is denoted f inverse, okay, f to the negative first power, and is read as f inverse. So you should always say f inverse, f inverse. If I ask you for f inverse, you're finding the inverse function, all right? Now, one thing that you might notice, this is a table of values for those functions that are above. So one is the original function is the blue, and the black is the inverse function, and that's the red down here. So if you look at your x and your y values, we start with negative 2, 4. The inverse function is 4, negative 2. The original function has negative 1, 6. The inverse function has 6, negative 1. The original function has 0, 8. The inverse function has 8, 0. So you can kind of see at this point that your y's are the same as your x's for the inverse, and your x's for the original are the same as your y's for the inverse. So you literally take x and y and you swap it, which is why when you're solving for the inverse, you switch the roles of x and y, because you're taking x and you're taking y and you're flipping their places. So the inputs and the outputs, so the x and the y, in your graph are going to be opposites. Okay, that's why they reflect over that line. So the graph of an inverse function is a reflection of the graph of the original function. The line of reflection, that's what goes right here, is y equals x, just like I showed you above. So whenever you have a reflection, it doesn't always have to be over the x-axis. It can be over something else. In this case, it is that line, y equals x, the dotted line above. To find the inverse of a function algebraically, switch the roles of x and y, then solve for y. Okay? You switch x and y and solve for y. Switch x and y and solve for y. Switch x and y and solve for y. So get that in your head. That is what you do to find an inverse. So let's do another example. Turn your paper over. We're going to find the inverse of this function, but we're going to find it when x is greater than or equal to 0. Okay? So we're limited with our x's, but that's okay. Let's go ahead and make f of x a y. So let's make this y equals x squared minus 2, and then we swap x and y. Swap x and y and solve for y. So we have x equals y squared minus 2, and then we solve for y. So when we solve this for y, we need to first get rid of that 2. So we add 2. X plus 2 equals y squared. To get rid of a square, you take a square root because that is its inverse function. And when you take the square root, you always have two answers, the positive and the negative. So we get positive, negative x plus 2. Now, remember we have to write it as f inverse. So f inverse of x is plus or minus the square root of x plus 2. Now, when we're graphing, you can make a table of values. So let's make a table of values for the original function f of x. Okay. Now it says that you can only use x values that are greater than or equal to 0, which means that we need to pick 0, 1, 2, 3, and so on and so forth. So when you plug 0 in, you get negative 2, and again, we're plugging it into this function right here. When you plug in 1, 1 squared is 1, minus 2 is negative 1. 2 squared is 4 minus 2 is 2. 3 squared is 9 minus 2 is 7. So that's enough to get us a picture. So we plot those points. We go to 0, -2. We go to 1, -1. We go to 2, 2. And we go to 3, 7. So this is half of a parabola because we're restricting our domain, the x values that you can plug in, to just numbers greater than 0. If this were a normal parabola, you would see both sides, but we only see one, and that's okay. That just means you have to follow that restriction. Now, once we have found those 2 points, remember, when you find the inverse, you flip x and y. So we don't have to do any work to find our table of values for f inverse. All you have to do is take your x's that are right here and put them in your y slot. So we are going to get out 0, 1, 2, 3, and we put our x's, or f of x's, into x. So we have -2, -1, 2, and 7. Those are our points now, and those are easy to graph as well. We go to -2, 0, -1, 1, 2, 2, and 7, 3. So 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7, and 3. So that is our function. And remember, we have to make sure it reflects over that line, the wonderful line, and it does. Because when you draw that line, that is your y equals x. You can see that they are mirror images of each other. They are reflections, definitely. All right, so there's one more thing we have to be able to do, and that is determine whether our inverse function is a function. Is the inverse an actual function? Now remember, a function means that it passes the vertical line test. So if you take it and you flip it on its side, because you're reflecting it over the line y equals x, it has to pass the vertical line test in order to be a function, which means that we can use this horizontal line test to see if it is a function just looking at the original. So if it is a function, then the horizontal line test works. It can only touch one time. If it's not a function, it touches more than once. Okay, just like in this parabola. You can see that that line goes across our function twice. If it happens more than once, then this is not a function. That's bad. Well, it's not bad. It's just a fact. So let's see if this is going to be a function. So in order to find out if it's a function, we should probably graph it. And again, desmos.com, but you need 3 good points. You're not just graphing willy-nilly, you need to find good points. And so I have found a couple of good points. I have found the points where x, I'm sorry, that's f of x, is -1, 0, and 1. Okay, those are fine points. And we get -3, -5, and -3. So that's what this looks like. And there's our parabola. So we are going to test and see if the horizontal line test works. So in order to do that, you put a straight line that's horizontal through your graph. So like this. Well, that touches our parabola twice, which means that this is not a function. So the answer to answer this question is no. The inverse is not a function because it does not pass the horizontal line test. Now, the instructions tell us to find the inverse and graph it. So we could graph it pretty easily because all you have to do is take your x and your f of x and swap them. Okay, not too bad. But let's go ahead and find the function first. So we get, what do we get? We have to make f of x y. So we have y equal to 2x squared minus 5. And then we swap x and y, so we get x equal to 2y squared minus 5. add 5 to both sides to start solving for y. X plus 5 equals 2y squared. Remember, you cannot get rid of a square until you get rid of that 2, so we need to divide by 2. So that x plus 5 over 2 equals y squared. Then we need to take the square root, because the square root is the inverse of a square. And when you take the square root, you get how many answers? 2, the plus and the minus. Do not forget that. So your function, your f inverse function of x is plus or minus the square root of x plus 5 over 2. And again, finding the inverse points is very easy because you can swap x and f of x. So we have x and f inverse. So instead of the negative 1, 0, 1 being in the x, it goes here. And that's a 1. And instead of negative 3, negative 5, 3 being in the f of x, it goes in the x. So we have negative 3, negative 1, 0, negative 5, and 1, negative 3, 1. Just one more thing, if we draw that line, this is a reflection. So that does exactly what we needed it to. That's it. Have a great day.